Okay guys, last video for chapter 19. Okay, I'm just going to run through a few problems in this one so you can kind of actually see now how we're going to do a significance test, and then you're going to also see for the first time the calculation part of it. So we're going to follow 4 major steps in performing a significance test. So here's just kind of just a real quick example, very, very, very basic. So a basketball player claims to be an 80% free throw shooter. In an SRS of 50 free throws, he made 32. So his sample proportion here would be 32 out of 50, or 0.64, which is much lower than he claimed. So does it provide convincing evidence, though, against his claim? Okay, so the first kind of step that we're gonna do is what we did for most of the first video, which was make our hypotheses, state our claims in the form of a hypothesis. So for this quick problem, our null hypothesis is that the proportion would be 80% or 0.8, and our alternative hypothesis is that we're looking to see if we have strong enough evidence to show that it would be less than the 80% or 0.8, because we have that proportion that said it was 0.64, so we're kind of leaning that it's going to be less than what he's saying, or she. Where P is the actual proportion of free throws the shooter makes in the long run. Okay, so the next step that you're going to do, much similar to what we've been doing it for confidence intervals, which is to model the distribution. Okay, so that means that we're looking to see if it's normal. So if we want to see if it's normal, we want to check our conditions, okay? So our random condition, independent assumption, and our large counts, or our success failure condition, okay? So for our basketball problem, so obviously it's random because it said it was an SRS of 50 free throws, okay? So that part of it is good. Or 10%, I would have to think that, I would assume that 50 would be less than or equal to 10% of free throws, I don't know, let's say in a season of basketball. And then for our large counts, we want to check n times p being greater than or equal to 40. That's 10. Well, that's going to be 40. And then, because it's 50 times 0.8. And then n times 1 minus p to also be greater than or equal to 10. So, and here 50 again. This time 0.2, which is 10, which is equal to, but it has to be greater than or equal to, so we're good on our large counts, okay? So because of that, we can now say that we think it's normally distributed. We know that my standard deviation here, and it's back to standard deviation. It's not a standard error anymore, because 0.8 is what the population would be. It's not based off of the sample over your sample size. So success fail over sample size is going to get you a standard deviation of 0.0565. So just as far as what our sketch would look like, we have centered at Oh, I kind of ran out of room over there. I'm going to do it up here. Okay, so we're centered at the 0.8. So one standard deviation would be 0.8565. Two standard deviations would be 0.973. 2. Ran out of room again. Opposite direction, 0.7434. And two standard deviations in this direction will bring you to 0.6868. So you know that 6,4 would be maybe somewhere there, and we're talking about that area under the curve. Okay, next thing we're talking mechanics. So these are our calculations that have to be made. So a significance test uses sample data to measure the strength of evidence against the null hypothesis. So here are some principles that apply to most tests. The test compares a statistic calculated from sample data with the value of the parameter stated in the null hypothesis. Values of the statistic far from the null parameter value in the direction specified by the alternative hypothesis give evidence against the null hypothesis. So it's this test statistic that we are going to find our p-value in order to be able to measure whether we're going to reject the null hypothesis or if we're going to fail to reject the null hypothesis. Okay, so it follows this general form. I believe it's on your reference sheets. So your test statistic is going to be your statistic minus your parameter over the standard deviation of your statistic. So as far as our basketball problem that we just had would be concerned, is our statistic was 0.64. 80.8 was our parameter, and then we found our standard deviation was 0.565. So this is going to give you negative 2.83. Okay, so that's like a z-score here. It's not is like, it is a z-score. So what you're doing is you're wanting to find the probability that your proportion be less than or equal to the negative 2.83. Okay, so I'm going to kind of put this over here. So how to find that is by taking norm CDF. I ran out of room. I'm going to put it over here. We're going to do norm CDF of negative 1,000, let's say, to negative 2.83. Okay, so you're looking for that, our curve that was on the last one, that little piece over there, okay, where that's the negative 2.83. Okay, it's standardized, so because it's already, the negative 2.83 is standardized, so you don't have to put in a mean or a standard deviation, just 0 and 1. And so your answer here is just, it's a really, really small number, something like that. Okay, and so because this is a very small number, it is less than 1%. It's 0.23%. Okay, this would tell us that if the null hypothesis, if he actually shot free throws 80% of the time, or he made 80% of his free throws, that are us getting, I think it was 32 out of 50, would only happen in 0.23%. So that's too small to just happen by chance, okay? This would imply that there would be a problem with your null hypothesis, that it didn't just occur by chance, but that the null hypothesis is is incorrect. So we would reject the null hypothesis with a p-value this small. So then your last step is just to conclude, which I already did on the last page. Because my p-value there, 0.0023, was so small, I'm going to actually reject my null hypothesis. I would conclude that the actual proportion of made shots would be less than 80%. Okay, so now let's run through a few problems. So we could get the hang of it. Okay, so a potato chip producer has just received a truckload of potatoes from its main supplier. If the producer determines that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load from the supplier. A supervisor selects a random sample of 500 potatoes from the truck. An inspection reveals that 47 of the potatoes have blemishes. What should the producer conclude? Okay, so the first thing is, here is our hypotheses. So our null hypothesis is that 8%, what is it? 8% determines that 8% have blemishes, okay? The alternative hypothesis is that it's going to be more than 8%. P is going to be the actual proportion of potatoes in the shipment with blemishes. The next thing we're going to do is see if our conditions are met in order for us to assume it's normal distribution. So it's random. They said that they took a random sample of 500. And we can assume it's normal. So your expected here it is. Your expected successes were 40, which is definitely over 10. Your expected fails, 460, definitely over 10. And then finally, it's independent because we're sampling without replacement. We need to check the 10%. But it would seem reasonable that there are at least 5,000 potatoes in the shipment. So I think it's safe to say that the 500 would be less than or equal to 10%. So now that we know that, we're going to start to work on the mechanics, so the numbers. So our proportion here would be 47 out of 500, or 0.094. We now have to find my test statistic. So I do my sample proportion minus my population proportion. I put it over my standard deviation. So it's going to give me a value of 1.15. I'm then going to either use table A, but you're not going to use table A, or your calculator, which is a much more logical thing to do. You're going to sketch the graph, okay? Put down a few standard deviations, show where you're looking to shade or find the probability of that, and then you could put norm CDF, 1.15 to 100 or 1,000 or 999, as I do often, okay? You're just showing, and it's standardized, so you don't have to change the mean or standard deviation. It would just be 0 and 1, okay? And then this was one-sided, so we're just going to find the probability that our alternative hypothesis that it was going to be greater than, so that it's greater than or equal to 1.15 would give you a p-value of 0.1251. So our p-value is not a very small probability. It's not 12.5%. I mean, is it a smaller number? Yes, but is that small enough that it wouldn't likely happen by chance? No, something like 12.5, that could happen just by chance. So that wouldn't be enough to prove that the null hypothesis is not true. So we have to fail to reject your null hypothesis. Your evidence is not strong enough to conclude that there's more than 8% blemished potatoes. There might be, but your evidence doesn't show it. So you're going to fail to reject. Don't accept it, but just fail to reject it. Okay, let's take a quick look at a two-sided example and then be done with this video. So according to the Centers for Disease Control and Prevention website, 50% of high school students have never smoked a cigarette. Tyon wonders whether the national result holds true in his large urban high school. For his AP Stats class project, Tyon surveys an SRS of 150 students from his school. He gets responses from 150 students, and 90 say that they have never smoked a cigarette. What should he conclude? Okay, so we want to perform a test. Don't worry about the significance level. We'll be getting into that in our next chapter, in chapter 20. Our null hypothesis here would be 0.50. And our alternative hypothesis is that it's not going to be 50. It doesn't really say more or less. It just says he wonders whether the national results hold true in his high school. So he's not saying that he wants to say if it's more than his high school or less than his high school. He just wants to know if it's true for his high school. So now he's got to check the conditions in order to see if he can assume it's a normal distribution. So he says it's an SRS. It's normal, so you're expecting 75. You're expecting 75 successes and 75 fails. Both of those are at least 10. And finally, it's independent. So I think it's reasonable to assume that that 150 is less than or equal to 10%, which would be 1,500 in a large high school. So now that we know that it's approximately normal, we could sketch our graph, we could find our test statistic, and then we could find the probability of our test statistic. So our proportion here is going to be 0.60. Our test statistic, take your sample proportion, subtract it from your population, divide it by your standard deviation, you're going to get 2.45. So for a p-value, it's a little bit different because for a p-value, you're actually looking for almost like two parts of it here because it's a two. Your alternative hypothesis was a two-sided test. So because it's two-sided, it's not just it's not just less than or greater than, but it's both. So you're looking at two parts of the graph here. Okay, your z-score, though, your test statistic, that's only going to get you one of them, okay? Which means you have to find the probability that it would be 2.45, and then you'd have to multiply it by 2 because that occurs on two sides of the curve. So it's at negative 2.45 and at positive 2.45. So you would want to do 2 times the probability that the z is greater than or equal to 2.45. Okay, so it's going to give you an answer of 0.0142. So this now is a very small p-value. So here your p-value only 1.4%. So this would be sufficient evidence, this would be strong enough evidence to say that we can reject our null hypothesis and conclude that the proportion of students at Tyon School who say they have never smoked differs from the national result of 0.50. So it could be more, could be less. We don't know about that. We just know it can differ. It can be different than the null hypothesis. Okay. There are calculators used here. Your calculator can do run a significance test, but I will demonstrate that in class. And we'll work on more examples to clarify everything. But that is the end of the videos.